Pop quiz. If you travel from Earth to the Moon, what changes? A. Mass only. B. Weight only. C. Both mass and weight. Or D. Neither. Lock in your answer. We'll reveal it soon. In this video, you'll learn the difference between mass and weight, how gravity fits into the picture, and how to calculate real numbers you can trust in science in everyday life. Start with Newton's second law. Force equals mass times acceleration. When the only acceleration is gravity and you're standing on solid ground, the force you feel as weight is mg. In other words, your weight equals your mass times g. Now, to truly understand that, we need to separate mass and weight. Mass is how much matter is in an object. It stays the same wherever you go. Weight, on the other hand, is the gravitational pull on that mass, so it changes if g changes. We measure mass in kilograms and weight in newtons. So where does gravity come in? Gravity is not identical everywhere. Near Earth's surface, g is about 9.81 meters per second squared. On the Moon, g is about 1.62. On Mars, about 3.71. And on Jupiter, over 24. Different g means different weight for the same mass. Let's make this concrete with an example. A 12-kilogram backpack on Earth has a weight equal to 12 times 9.81, about 118 newtons. On the Moon, 12 times 1.62 gives about 19 newtons. Same mass, very different weight. Now, back to our quiz. The correct answer is B, weight only. Your mass is the same on Earth and on the Moon, but your weight changes because g changes. Before we wrap up, watch out for 3 common mix-ups. First, everyday language often says weight when it really means mass. Second, pounds are a unit of force, while newtons are the scientific unit for weight. Third, as you move farther from the planet, gravity gets weaker, so true weight decreases. So to summarize, mass is constant and measured in kilograms, while weight equals mass times g and is measured in newtons. Want to lock this in? Your personalized practice test and flashcard set are all waiting for you. Tap the link and give yourself a quick check. Let's deepen the idea with apparent weight. When you're in an elevator speeding upward, your scale reading increases because you need extra upward force to accelerate. In general, apparent weight is mass times the quantity g plus or minus a, depending on the direction of acceleration. For example, suppose your mass is 75 kilograms and the elevator accelerates upward at 2 meters per second squared. That apparent weight equals 75 times the quantity 9.81 plus 2, which is about 886 newtons. If the elevator instead starts moving downward with the same acceleration, the reading would drop. Now, what about astronauts who feel weightless? In orbit, they are in continuous freefall, so the floor does not push on them. The true gravitational pull is still there, but the contact force is nearly zero, so they feel weightless, even though their mass never changed. To tie this all together, here's a quick recipe. 1. Pick the right value of g for your location. 2. Multiply mass by g. 3. Label the result in newtons. 4. If the situation involves acceleration, adjust with g plus or minus a to find the apparent weight. To recap, mass is the amount of matter and does not depend on location. Weight is the gravitational force and equals mass times g, so it changes with g. In accelerating situations, your apparent weight reflects g plus or minus the acceleration. Now that you've watched the video, let's see how much you remember. Head to the link in the description where you'll find Quizlet content made just for you.